So welcome once again. Let's move on towards our next topic, which is called as central force. So let us assume that let a force acting on a particle of mass m. Okay, suppose a force is acting on a particle of mass m, and the force is as follows: that it is directed from m towards or away from a fixed point O. So suppose this is your fixed point O, then the force which acts on this particle P is either directed towards it or away from it. Okay, so either the force will be from P towards O, or either the force will be from O towards P. Okay, so either the force can be attractive or repulsive. So either from P to O will be the force, or from O to P. So it is directed from M toward. Okay, so this is your mass M, that is toward either away. Okay, so both the cases are possible, but it will be along this particular line only. It will be along this particular line only. That's what is meant by this. It is directed from M toward or away from a fixed point O. Its magnitude depends only on distance r from O. So its magnitude, the magnitude of this particular force only depends on the distance r from this particular point O. So the magnitude of this particular force only depends on the distance r. So this particular distance, the position vector is r vector, and the distance will be r, right? So magnitude depends only on distance r from this particular point O. Then the force is known as central force. Such a particular force which depends on the magnitude of position vector, and it is either directed towards O, that is towards the origin, or away from the origin. That is only along the line joining the mass and the origin. That is only along the position vector. The direction of force is only along the position vector, and the magnitude of force is dependent only on the position vector's magnitude. Okay, so such a force is known as central force or central force field, with O as the center of force. Okay, so it is either called a central force, or you may call it central force field, where O is what? Center of the force. In symbols, F vector is a central force. IFF means if and only if. Okay, so if this holds good, then it is a central force, and if it is a central force, then this holds good. What is meant by IFF? IFF means necessary and sufficient condition. So if F is a central force, then this condition will be satisfied, and if this condition will be satisfied, then F will be a central force. So both imply each other. So in symbols, F vector is a central force. IFF, F vector equal to F of r hat. Okay, F of r means only dependent on the magnitude of this r. Okay, r is a vector, and its magnitude will be written only as r. So F vector will be equal to F of r, that is a function of the radius vector. Radius vector means the position vector. So function of position vector r hat means either directed towards the position vector, or either directed away from the position vector. That is only along the direction of r hat. Okay, so unit vector along the direction of r vector will be r hat, right? Unit vector along the direction of r vector will be r hat, and the force F will be either directed towards the origin O or away from the origin O. Okay, so the r hat will either lie towards this, or that is your r hat will be along this direction only, but your f of r, depending whether f of r is positive or negative. If f of r is negative, then the force will be towards O. If f of r is positive, then the force will be away from this particular line joining the mass and the origin. Okay, that is the position vector. So this is the thing. Now r hat can be written as r vector divided by r. Okay, r vector divided by, that is vector r divided by magnitude of r. That's what is r hat. Okay, now r hat is the radial unit vector. You must understand this thing very well, that r hat is a radial unit vector. So in symbols, F vector is a central force IFF if this particular condition is satisfied. Now from r hat, how we have arrived at this, we know this very well, that r vector equal to r hat. Okay, so if you want to find out r hat from here, it will be r vector divided by r. So that's how you have got this particular term. Okay, so hopefully it is clear to you. Now if f of r is smaller than 0, what will happen? If suppose f of r is smaller than 0, then the negative value will come over here, and if negative value will come over here, it will be along the direction of minus r hat. The r hat direction is this, and if f of r is negative, minus r hat will come. So minus r hat means this particular direction. If f of r is positive, suppose, then what will happen? Then positive direction of means r hat plus r hat will come. So plus r hat means this particular direction, plus r hat means this particular direction, that is repulsive. Okay, so f of r is smaller than 0, then central force is attractive towards O. Okay, f of r is negative, so minus r hat will come, that is attractive towards O. If f of r is positive, plus r hat will come, that is repulsive away from O. Okay, That is the thing. In an alternative way, central force is defined as negative gradient of scalar potential or potential energy. Now you must know this very well, that potential and potential energy are the words potential and potential energy. Both are used interchangeably in higher mechanics, higher classical mechanics, and in quantum mechanics. Yeah, although at lower level in 11th and 12th standard, potential and potential energy are defined separately, but at higher levels, that is higher classical mechanics and quantum mechanics, potential and potential energy are used interchangeably often. Okay, so they are used interchangeably often. So in an alternative way, central force is defined as negative gradient of scalar potential or potential energy. This fact you must remember, that F vector equal to negative gradient of V of R. Okay, so negative gradient of V of R means minus inverted triangle. Okay, its symbol is minus inverted triangle. So gradient symbol is inverted triangle. So it is defined like this. Okay, it is defined something like this. So so F vector will be equal to negative gradient of potential, and when you put the VR function, that is potential, which is a function of radius vector, that is position vector. What is potential? Potential will be a function of position vector, right? So not position vector, that is magnitude of potential vector. Okay, position vector. So magnitude of position vector will be R. Position vector is R vector. So magnitude of position vector will be R. So V of R, what is V of R? V of R means potential being a function of position vector magnitude. Potential being a function of position vector magnitude. Okay. So potential is a function of position vector magnitude. Potential is a function of position vector magnitude, and when you try to take its negative gradient, you obtain the value of force. So this is the value in Cartesian coordinates. Okay, I cap del by del x plus j cap del by del y plus k cap del by del z. Okay, this is how this inverted triangle is defined. So and it is called as gradient. So gradient operator is like this, and when you apply this gradient operator on this particular v of r function, that is potential being a function of position vector magnitude. So v of r function, when you apply this particular function on this operator, this particular operator on this particular function, then you get the force vector. Okay. So examples, what are the examples of central force? Gravitational force. So the gravitational force on m due to m naught. Now m naught and m are there. So gravitational force on m, this particular mass due to this m naught, what will it be equal to? From the 11th standard definition, you can write F vector equal to minus g mm naught r square. Okay, minus g m1 m2 divided by r square, right? You have learnt already the universal gravitational constant g and this formula, that g m1 m2 divided by r square. So gravitational force on this particular mass m due to this m naught will be obviously attractive, because gravitational force is always attractive. Okay, so as gravitational force is always attractive, so it will be directed towards minus r. Okay, because from m naught to m the position vector will be r. Now when the force force on m will be attractive in nature, so it will act towards minus r hat. Okay, the force on m due to m naught will be towards minus r hat. Why? Because minus r hat is the direction which is attractive, that is towards m naught. Okay, and r hat direction will be this, and minus r hat direction will be this. So as the force is attractive, so minus sign we have to apply, and magnitude will be g m1 m2 divided by r square. So m1 is m over here and m2 is m naught over here, and the distance magnitude is actually displacement magnitude, that is the position vector magnitude, is actually r. So g m1 m2 divided by r square. So g m naught divided by r square r hat. Now F vector equal to F of r hat. Now this F of r is your g m naught divided by r square, that is attractive force, that's why negative sign is there. And the other reason for negative sign, one of the reason for negative sign is it is attractive. Another reason is why it is negative, why attractive force is taken as negative, because it acts towards the attractive force acts in opposite. Attractive force acts in opposite direction of position vector connecting the 2 points. Attractive force acts in opposite direction. Okay, attractive force, this is the direction of r hat. So attractive force acts in opposite direction of r hat. Okay, that's why negative sign is there, right? So you must remember all these things. So F vector equal to F of r hat, F of r equal to minus g mm naught by r square, that is attractive force. Then electrostatic force or Coulombian force is also like that. So it is clearly a central force. Why it is a central force? You can see over here, we can represent it like this. Okay, we are able to represent this particular function in terms of F of r, that is it is a function of r. This term is a function of r, right? and another thing is r hat is also there in it. So it is matching the general formula. There is a general definition of central force. It is matching that. So gravitational force is a central force. Similarly, you can apply the same logic for electrostatic force also. But unlike gravitational force, which is always attractive in nature, your gravitational force is what? It is always attractive in nature. But your electrostatic force or Coulombian force can be either attractive or repulsive. Okay, it will be repulsive when like charges are there. When like charges are there, like plus, minus, then repulsive force will act. And plus, minus, attractive force, minus, plus, attractive force, because opposite charges in electrostatics attract each other, and similar charges in electrostatics repel each other, right? So electrostatic force on plus minus q due to plus minus q naught. So on plus minus q due to plus minus q naught, electrostatic force, what will it be equal to? F vector equal to 1 upon 4 pi epsilon naught q naught divided by r square r hat. So why it is positive? Because it is repulsive force. Repulsive force means in the direction of r hat. Repulsive force means in the direction of r hat. That is why a 1 upon 4 pi epsilon naught q1 q2 divided by r square. So q1 q2 will be replaced by q and q naught, and r hat will be the direction that is towards this. That is r hat also has this direction only, and the repulsive force also has this direction only. Okay, so repulsive force and r hat both have the same direction. That's why positive sign. So repulsion is that's why shown with a positive sign. Okay, so f of r equal to 1 upon 4 pi epsilon naught q naught divided by r square equal to positive. That is your repulsion. So this is clearly so you are able to represent electrostatic force also as f of r hat. Okay, you are able to represent electrostatic force also in terms of the definition of central force. So definition of central force says that whatever force it may be, if it is being able to be represented, if the force is being able to be represented like this, that f of r hat, like this it can be represented. So if it can be represented in the form f of r hat, then it is a central force, and electrostatic force was able to be represented like this. So that's why electrostatic force is also a central force. So f of r, now this particular term is f of r, right? This particular term is what? F of r, because it is a function of r. Other things will remain constant. 1 upon 4 pi epsilon naught q naught, everything is constant. Only r will change. Only r is variable over here. For a system q naught and 1 upon 4 pi epsilon naught, those things will remain constant. So 1 upon 4 pi epsilon naught is a universal constant. q naught are same for a fixed system. So we can vary the r. So only it will be a function of r only, right? Only a function of r. So you can imagine it like this. So f of r equal to 1 upon 4 pi epsilon naught q naught divided by r square equal to positive, that is repulsion. So that is the thing. And in this particular case it will be attractive, because if it is plus over here, it is minus over here. If it is minus over here, then it is plus over here. So it is attractive force clearly. That is, it will act in the minus r hat direction. Okay, so that is the thing. So now electrostatic force on minus plus q due to plus minus q naught, what will it be equal to? F vector equal to minus 1 upon 4 pi epsilon naught q naught divided by r square r hat. How did this come? The same formula, but the signs will be opposite. Okay, so if you take this to be plus, then this will be minus. If you take this to be minus, then this will be plus. So plus into minus will be minus. So that's why negative sign is coming over here. In case of gravitation, always negative sign was coming, but in this particular case, when the charges will be opposite, only then negative sign will come. Okay, so electrostatic force on minus plus q due to plus minus q naught, that will be equal to f vector equal to minus 1 upon 4 pi epsilon naught q naught divided by r square r hat. That is, this particular term is your f of r, and negative sign denotes your attraction. So towards the minus r hat direction, that's why it is attractive. Okay, so this negative sign also you can apply with this vector and see whether it is attractive or repulsive. If you take this minus sign along with this r hat, then you will realize that the r hat direction is this. What is the direction of r hat? R hat direction is this. That is the unit vector along this direction. Okay, and the opposite, the attractive force will be opposite to that. So it will be attractive force will be in the direction of minus r hat, right? So that is the thing. So that's how you can even see that whether attractive or repulsive electrostatic force is, electrostatic force is always central force. That also you can see over here, because this particular quantity is f of r, that is a function of r only, because q naught will be a constant, 1 upon 4 pi epsilon naught will be a constant, and q naught you cannot vary, because this is a fixed system, right? Only you can vary the distance. You can only vary the distance. q naught will be fixed, and 1 upon 4 pi epsilon naught is already fixed, because it is a universal constant. So that's how you can understand. So f of r equal to minus 1 upon 4 pi epsilon naught q naught by r square equal to negative, that is your attraction. Now properties of central force. Let's move on towards the properties of central force. The path or orbit of a particle moving under a central force is a plane curve. So the path of a particle moving under a central force is always a plane curve. Okay, it will never go in three dimension. What is the three dimensional curve? Let me tell you what is a three dimensional curve. If you take a curve like this, okay, if you take a curve of this kind, okay, in this particular curve, if this is going below the screen of laptop, this particular part is on the screen of laptop, and this is coming in front of the screen of laptop. Okay, so let me mark with different colors. This is suppose behind the screen of laptop. This particular marked with red color is suppose on the screen of laptop, and this particular marked with yellow color is in front of the screen of laptop. Then what will happen? This particular curve is 3D curve. Okay, this particular curve is what? It is a 3D curve, three dimensional curve. Okay, it is not a 2D curve. Now what is a two dimensional curve? Two dimensional curve is such a curve which you can draw on the paper. So all the curves which you are able to draw on the paper, all these curves will be what? All these curves will be planar curves. Okay, so you only have to take into account the planar curves in case of central forces, because whenever central force acts, the path or trajectory that is traced by a particle will be always planar. It can never be non-planar. Okay, it will always be a planar curve. Okay, so the path or orbit of a particle moving under a central force is a plane curve. With proof we will see it. So suppose O is the origin, R is the position vector of a particular point P on this particular trajectory, and this is the point on which the central force is acting. So force acting on the particle is F vector equal to F of R hat. Okay, so force acting on this particular point P, what is it equal to? So the force capital F equal to F of R hat, and F of R will remain as it is. R hat will become R vector divided by R. Okay, what is R vector? R hat vector, by the definition of vector, any unit vector in the direction of any vector. Okay, the R hat is what? Unit vector in the direction of this position vector. R hat is unit vector in direction of this position vector. So unit vector in direction of any position vector can be written in terms of R vector divided by R. It can be written like that, because you already have by the definition you have R equal to R hat, right? By the definition of vector. So unit vector in the direction of R vector, what will it be equal to? So it will be basically the vector divided by its magnitude. Okay, vector divided by its magnitude will be the unit vector along that direction. Okay, so that is the thing, because when you divide R vector divided by R, so the magnitude becomes 1, and R hat as a magnitude 1. This R hat, what is the magnitude of this R hat? R hat means unit vector, so it has a magnitude equal to 1. So proof or explanation: force acting on the particle, what will it be equal to? F vector equal to F of R hat. So F of R as it is, and R vector divided by R we have written. Now torque acting on the particle due to F. Now let us understand this also. Let me teach very fast so that we are able to complete the course on time. So torque acting on the particle due to F. Now torque acting on this particular particle P due to the force F. How will the torque be written? So the torque can be written relative to O. Okay, relative to this particular point O we are talking, because torque is always defined with respect to a particular point. Torque is never defined like this only. Okay, torque is never defined only in thin air. Okay, so torque is never defined only in thin air. Torque will be defined always with respect to a fixed point. Okay, only then torque can be defined. Torque cannot be defined just like that. Like force you can define anyways. Okay, without defining any point you can define force. Okay, but torque you cannot define like that. Torque you have to always take with respect to a particular point. So torque acting on a particle due to F relative to point O. Then how will you write the torque? Torque vector equal to R vector cross F vector. You must have learned from the definition that R vector cross F vector is the torque. Okay, so R vector cross F vector, this is suppose your F vector direction. Then what will happen? R cross F. Okay, that is the thing. That is how you will take. And I have already told you how to define direction in case of cross vectors. Okay, cross product. So torque vector equal to R cross F. Now R remains as it is, and F vector. Now F is a central force, right? What is F? F is a central force. So what will happen? As it is a central force, so it can be written like this, and as it can be written right like this. So F of R and R you remove from here, and R cross R you can take, and R cross R becomes 0. Why will it become 0? Because cross product of any vector with itself. Cross product of any vector with itself is what? Cross product of any vector with itself is 0. So this particular quantity becomes 0. So torque vector equal to 0 over here. So you got this hopefully, and there is nothing in it. You have just substituted the definition of central force, and as we are talking about central force, so F can be replaced by this, and when as soon as you replace f by this particular quantity, r cross r will come in the expression, and r cross r will be equal to your 0, because cross product of any vector with itself is 0, and you can also determine it by the expansion of sign product, cross product. Okay, how do you expand the cross product? R into r sine 0 r hat. Okay, how will you define it? R cross r, so that will be your r into r sine theta, n hat. Okay, so r into r sine theta, sine 0, in place of sine theta there will be sine 0, sine 0 is 0, so r cross r is 0. Okay, so torque equal to 0. So this is the, so torque will always be 0 in case of central force. Okay, in case of central force, torque will always be 0 with respect to the origin. Please remember this thing. Okay, torque will be 0, but only in case of torque being taken with respect to origin. Okay, if you take torque from some other point, if suppose you take torque with respect to this point, in that case also it will be 0 only, then the origin will be this. Okay, so torque will be always 0. Yes, you are right, torque will be always 0, no doubt about it. Okay, because as soon as you change the point, suppose you change the point from O to O prime, if you take this particular point and you want to find out the torque about this particular point, then the position vector r will change to this. Okay, and the position vector r, as soon as it changes to this, what will happen? The direction of force will be also like this, right? So it will be with respect to this particular point. So anyways, let me come back to this point. So torque equal to dj vector by dt, that is j vector is equal to angular momentum of the particle, and dj vector by dt equal to 0. Why will it be equal to 0? We have already proved. Okay, so this torque is equal to 0, so this particular quantity is 0, so dj vector by dt equal to 0, and the differentiation of any quantity, if it is equal to 0, so that quantity is a constant, so j vector will be a constant, that's why. So j vector is a constant, so equation 2, this was equation 1. Now, but j vector equal to r vector cross p vector, already we know r vector is like this, p vector can be written as mv vector, then j vector is a constant, both its magnitude and direction. Now j vector is constant. If a vector is constant, what does it mean? If a vector is constant, that means that, if a vector is constant, it means that the direction of the vector is also constant and the magnitude of the vector is also constant. That's what is meant by a vector being constant. So whenever a vector is constant, whenever we say that its magnitude is also constant, its direction is also constant, because j vector can be written, j vector is a constant, and j vector can be written like this, that it can be written j hat. Okay, so if j hat is constant, so that means that this particular thing is also constant and this particular thing is also constant, that is the direction of this is not changing, the magnitude of this is not changing, so both the magnitude and direction are constant. Now j vector equal to r cross p, so r cross mv, j is constant, both its magnitude and direction are constant. From equation 3, what is the thing? Now from equation 3, you know this very well, whenever you take the cross product of two vectors, the resulting direction will be perpendicular. Okay, resulting direction of this cross product, from the definition of cross product we know this very well. How to find the direction of resulting, how to find the resulting direction out of cross product, I have already told to you in the previous lectures how to find the resulting direction out of cross products. So this is suppose your r vector and this is suppose your v vector. So how will you find the resulting direction? You are doing r cross v, so you are moving from here to here, so just curl your fingers, of right hand, in such a way that the nails of the right hand are in the direction of arrow. Okay, so the direction of thumb will be inside the laptop. Okay, direction of thumb from right hand thumb rule, the direction of thumb will be inside the laptop. So the if the direction of j vector, if it is inside the laptop, then what will happen? Then certainly it is perpendicular to the plane containing this vector. So if the direction of j vector is inside the laptop, so it is certainly perpendicular to the laptop screen, and the laptop screen had r vector and v vector. The laptop screen had r vector and v vector, and j vector was perpendicular to the laptop screen. So j vector was perpendicular to r vector and g vector containing plane. Okay, so j vector is perpendicular to the plane containing r vector and v vector. Okay, hence the path of the particle under a central force must always lie in one plane. Okay, because j is constant. Okay, so the cross product is constant. As the cross product is constant, so r and v will be always in one plane only. Okay, so path of a particle under a central force must always lie in one plane, as r and v will be always in one plane, and in order to have the j vector always in one direction and perpendicular to a particular plane only, so the trajectory will be on that plane only. Okay, on that particular plane only. That is the plane containing the vectors r and v. Okay, in that plane only, that is the plane containing the vectors r and v. So the trajectory is a plane curve. Okay, hopefully you got this. So it is very clear. If you try to imagine it properly, you will certainly understand everything. Okay, if a particle moves in a central force field, its angular momentum is conserved. We have already proved this. Okay, and the third property, already proved this. Okay, we have already proved this in the previous class, I think, in the previous class, if I am not wrong. Okay, central force is a conservative force. A force is conservative if work done by it in a cyclic process is zero or circulation of the force is zero. Now we are going to prove that the central force is a conservative force. How are we going to prove this? We are going to prove this. Okay, just now. So force is conservative if work done by it in a cyclic process is zero or circulation of the force is zero. That is the definition of conservative force. You have already learned the definition of conservative force in lower classes. So a force is conservative if work done by it in a cyclic process. That is the cyclic integral. Okay, that is the path integral, cyclic integral, that is zero. That is the circulation of the force is zero. That is, if such a condition is there, that is, you take the line integral, from a to b to c to d to a. Okay, so the line integral, the closed line integral, curve integral we call it. So curve integral f dot dr equal to 0. This is the definition of conservative force. Now the central force is a conservative force. Okay, central force is a conservative force. So we are going to prove how central force is a conservative force. For the force to be conservative, this is the definition from the figure, f dot dr equal to 0, and along a closed path we are talking about. So a b c d a will be a closed path. So a b c d a is a closed path over here. Now just break this path into two parts, a b c one path and c d a another path. Okay, you have broken down this integral into two parts. Now just take this to the right hand side. What will happen? ABC will be like this, and instead of CDA, if you take the minus sign, what will happen? You are going from AD to C, you are going. So it will be ADC. Okay. Now path independence. So this shows that either you move. This shows what? This particular thing shows what? This shows that either you move like this from A to C, or either you move like this from A to C. In both the cases, the work done is the same. In both the cases. So it is showing you path independence, and if the work done is path independence, then what happens? That is a conservative force. Okay, so by Stokes theorem, what will happen? Now we are going to convert it into the form which we will show that it is a central force. Okay, so by Stokes theorem, it is like this. The Stokes theorem says something like this. Okay, so integration along the closed path f vector dot dr vector equal to integration along the surface s curl f vector dot ds vector. Now this is Stokes theorem. You have learned in the your engineering mathematics. You have already learned this Stokes theorem. I am not going to teach it over here because it is not a part of your syllabus. The only concept where this particular formula is useful is over here. In this particular concept only this formula is useful. Okay, otherwise nowhere in the physics optional you will ever use this formula. This is being used over here only. Okay, so just mug up this formula. Just mug it up. Okay, mug it up. Do not try to understand this particular formula. Just mug it up. Okay, mug it up. That's what I can say. So in order to qualify UPSC CSD as by taking physics as an optional subject, you have to mug up certain things. You cannot understand the entire, because you cannot be a physicist over here. You don't have that much of time. Okay, so by Stokes theorem, this is the thing. Okay, by Stokes theorem you have this. So if F is conservative or central force, then what will happen? Curl of this. Now if F is a central force or conservative force, the curl will be equal to 0. The curl of a central force is equal to 0. So this particular quantity will be equal to 0. This particular quantity will be equal to 0. Okay, So then curl F equal to 0. Okay, so this particular quantity, so you have already seen that this is 0, so this term will be in fact 0, because this is 0 from here, so this is 0, so this particular thing will be 0, so curl will be 0, curl F will be equal to 0. So curl of a central force is equal to 0. We have got this from here. So what we have learned from here, curl of a central force is equal to 0. That's what we have learned from here. Okay, now what is curl? Let us define curl. So curl F equal to your gradient, not gradient, gradient is different. Do not get confused between gradient and this. Okay, this is cross product. Okay, gradient is what? Gradient is like this over here. Okay, where is gradient? Gradient is like this. Okay, it is not cross product over here. Gradient is different. You are just applying this operator. Okay, without taking the cross product, you are just applying this operator on a function over here, and in that particular case which is seen over here, in this particular case we are taking the cross product instead. Okay, so I cap del by del x plus j cap del by del y plus k cap del by del z cross fx I cap plus fy j cap plus fz k cap. That's how. So that's how the curl is defined. Okay, inverted triangle cross f vector. Okay, so you call it gradient vector. So gradient vector cross f vector. So that's how you can do it. Now I cap j cap k cap del by del x del by del y del by z del z. How you take the cross product? These two rows will be always fixed. This particular row and this particular row are always going to be fixed, because this will be this particular row. Okay, so two rows will be always fixed in this particular case. You already know how to take the cross product. You have learned it in lower classes. How do you take the cross product? Suppose you have 2 I cap plus 3 j cap plus 4 k cap, and you want to take its cross product with 8 I cap plus 38 j cap plus 37 k cap, and you want to take the cross product. Okay, this cross this particular quantity. Then how do you take the cross product of these two? In determinant form I am saying. In determinant form you will put ijk. Okay, then you will put the symbol of determinant, then 2, then 3, then 4. That is the first vector. Okay, then the second vector is like this. So you will put the second vector 8, 38, 37, and then you will solve the determinant. How do you solve the determinant? You will first of all hide this, then you take the cross product over here. Okay, then what do? Then you hide this and this, then you take the cross product from here to here, here to here with the negative sign, then with the positive sign you hide this and you hide this, then you take the cross product here to here, here to here. Okay, so like that you solve the determinant. You have already learned it in the lower classes. So by solving this determinant you can find out the value of curl of any force, and if the curl of any force comes out to be 0, okay, if the curl of any force comes out to be 0, definitely that force will be central force. Okay, that force will be central force, because the curl has come out to be 0. As the curl has come out to be 0, that force is a central force. You must remember this thing. Okay, the total energy, that is sum of kinetic energy and potential energy of a particle moving under a central force, remains conserved. Okay, so total energy, that is sum of kinetic energy and sum of potential energy of a particle moving under a central force, remains conserved. So let us prove this particular term, that total energy, that is sum of kinetic energy and potential energy of a particle which is moving under central force, that sum remains conserved. Let us prove this particular fact. So central force acts in radial direction always. So we clearly have F equal to MAR. Okay, now AR is equal to this particular quantity. We have already learned this in the previous lectures. If you haven't watched the previous lectures, then I am not responsible. Okay, if you haven't watched the previous lectures, you should definitely go to the playlist and watch it from the beginning. Then you will understand each and every concept. Otherwise it will be very difficult for you to understand anything from here. Okay, so AR can be written like this, which we have already proved in the previous lectures, and central force acts in the radial direction. So this particular equation will hold, that is the force will be equal to MAR. and a theta component is already 0, transverse component is already 0, so only radial component will remain, and radial component is given like this. So this is the thing. So angular momentum of the particle, which is a constant, that will be equal to theta dot equal to j by mr square. Now in place of theta dot, just substitute this from here to here. Then when you substitute that, you get f equal to m bracket r double dot minus r j by mr square whole square. Okay, then what will happen? F of r equal to m into r double dot. This is the thing. Then this particular quantity whole square, r to the power 4 will come, 1 r will go with this, then it will become r cube. Okay, so f of r equal to m r double dot minus j square divided by m r cube. Then if v of r will be the potential energy of the particle, then what will happen? F of r equal to minus dv by dr. Okay, if v of r is the potential energy of the particle, then that's how is the minus dv by dr is the thing, that is the expression by which f of r will be defined, right? Negative gradient of potential, so minus dv by dr. Now, so this particular quantity f of r, it is equal to this much, and this minus dv by dr will be equal to this much. Okay, so this particular expression, how did this come? This particular expression is from lower classes. Okay, 11th and 12th. This particular expression is not new, it is from the lower classes, which you must remember while deriving this particular thing. So f of r equal to mr double dot this particular thing, then this is the fact. Then you will put this value minus dv by dr from here over here. Okay, so as soon as you put that, what will happen? This is the expression which you will get. So minus dv by dr equal to mr double dot minus j square divided by mr cube. Then mr double dot will be given like this. You have to arrange the terms basically. So this particular term, when you take it to the right hand side, what will happen? It will be erased from here, and it will go plus j square divided by mr cube will come. Okay, then what will happen? You will take the d by dr common from here, and as soon as you take d by dr common from here, this will be the expression. Now if you try to do the reverse thing, okay, if you try to solve this, you will get this only. Okay, if you try to solve this and you go backwards, then you will get this only. So this will be equal to this. Now you try to take the differentiation yourself, you will understand. Okay, what will be the differentiation of 1 by r square? D by dr, 1 by r square. So what will it be? Minus 2 divided by r cube will be there, right? Minus 2 divided by r cube will be there. So minus 2 will be cancelled, it will be minus 2 divided by r cube, so minus 2 will be cancelled by this, and one minus sign will come, so that is the minus sign. Okay, that is the minus sign over here. So that's how you can solve it, that's why it is plus over here. So you can solve this. These are quite obvious steps. I don't think there is any need to explain this such nursery steps. Okay, so multiplying both sides by r dot, what will happen? Multiply both sides by r dot. So over here mr double dot r dot equal to minus d by dr v plus j square by mr square. Over here also r dot. Okay, so then d by dt, if you try to take this thing, you can represent it like this. When you take the differentiation of this particular quantity, you will get this only eventually. Okay, so you can see easily that how these and these are equal. If you try to solve the differentiation, it will yield you this. Okay, now d by dr like this, then r dot is dr by dt, so r dot will be written as dr by dt. Then dr and dr, you can see that this dr and this dr, you cannot say that they are cancelled out, but you can think in your mind by common sense that this dr and dr are getting not cancelled. Actually in reality they are not getting cancelled, but we are assuming in our mind for our convenience that they are getting cancelled. It is wrong to say that dr and dr are cancelled. Why it is wrong to say so? Because dr is a differential quantity, it is not a number, so that's why you cannot call that this dr and this dr are getting cancelled. You cannot call it like that, it will be a blunder to say so. Okay, so d by dr by dt, this particular term is equal to d by dt. That's all you can say. Okay, what you can say is d by dr blanks dr by dt, this particular differential is equal to minus d by dt. That's how you can say. Okay, so this differential turns to this particular differential, so that's how you can see. Now minus d by dt of this particular term v plus j square divided by 2 mr square. Okay, so d by dt if you try to take, now just see over here also it is d by dt, and over here also it is d by dt. So if you try to take this particular term to the left hand side, if you take it, so this plus d, this, there is also d by dt over here and there is also d by dt over here, so both of them can be written with a common bracket. So both of them have been written with a common bracket, so they have been written with a common bracket over here. So d by dt half m r dot square plus j square divided by 2 m r square plus v, so that is equal to 0. Okay, now if you just try to see this particular term, d by dt of this whole term is equal to 0, so this whole term must be what? This whole term must be constant, only then its differentiation will be 0, because whenever differentiation of a particular quantity is 0, that particular quantity is a constant, right? You have already learned this, that whenever differential of a particular quantity is 0, that particular quantity is a constant. That particular quantity is a constant. Why? Because only constant yields 0 differentiation. So this particular quantity is a constant. So now in the place of j we have substituted mr square r dot mr square theta dot in place of j square, which we have already derived, that j is equal to what? J is equal to mr theta dot mr square theta dot. We have already derived this, j equal to mr square theta dot. We have already derived, so we have successfully substituted that, and plus v remains as it is. So this is as it is. Then this particular quantity you must expand, m square r to the power 4 theta dot square, then the r square and r to the power 4 will yield you r square, m square and m, so 1 m will be cancelled, so m will be there 1 by 2 as it is, and theta dot square, so theta dot square remains as it is, plus v remains as it is, so plus half m, okay, r dot square plus r theta dot square, okay, plus v equal to 0. Now how this has come? So you have taken half m constant as a common factor from here, so half m has been taken as common factor from here, r dot square r theta dot whole square, this is the thing, plus v as it is. Now this is clearly what? This is what? R dot is what? This r dot is clearly dr by dt. Now dr by dt is the radial component of velocity, we have already found out, and r theta dot is the transverse component of velocity, that is the v theta. So this will be your vr. This particular quantity is what? Radial component of velocity, because dr by dt is radial component of velocity as already seen in the previous lectures, and r theta dot is transverse component as velocity as already seen in the previous lectures. So half m vr square plus v theta square plus v equal to constant. So this particular quantity vr square plus v theta square, what is it equal to? It is equal to the total velocity, because radial component square plus transverse component square equal to total component square, right? This is quite a common sense thing. Okay, we have already seen this. Okay, if you take y component, what happens in Cartesian coordinate? In Cartesian coordinate, your total velocity magnitude square, magnitude of velocity square. How it is given in Cartesian coordinate? X component square plus y component square. That's how it is given in Cartesian coordinate. So similarly in polar coordinates, it will be given as radial component square plus transverse component square. So it will be magnitude of velocity square, right? So half mv square plus v equal to constant. So kinetic energy, this is what? Kinetic energy. So this is kinetic energy, so it is there, and this is v. So it is v is what? It is potential energy. V is your potential energy. So kinetic energy plus potential energy is equal to your constant. Okay. Now equation of path or orbit. Let us see the equation of path or orbit. Acceleration of a particle moving in a plane is, this is the acceleration of a particle moving in a plane. So this is the radial component of the acceleration of the particle, and this is the transverse component of the acceleration of the particle. Okay, so a vector equal to ar r hat plus a theta hat. Okay, we have already learned this, right, in the plane polar coordinates. In what? In plane polar coordinates. If motion takes place under a central force, then what will happen? A theta will be equal to 0, because transverse component of acceleration is 0 under a central force. So that's why a theta will be equal to 0. So this particular quantity is equal to 0. Now a vector equal to ar r hat. Okay, so as a vector equal to ar r hat, so a will be equal to ar, right? This is quite a common sense thing, right? Why it is a common sense thing? Because a vector points in the r hat direction. Okay, you can see from here that this particular quantity yields you 0. So your a will be equal to what? ar r hat. Okay, so that's how this particular quantity is 0, so vanished. So that's why this remained. Okay, so this is what it is remaining. Now how did this come? Okay, how did this particular thing came? Now this particular thing came from the fact that your acceleration points in which direction? As the transverse component of acceleration is 0, so your acceleration can be written as it is radially directed, because it is central force, so acceleration is radially directed, so it can be written as a r hat. Okay, right, because it is radially directed, and this particular quantity is equal to this, so a r hat. So r hat and r hat cancel from both the sides. So a equal to ar. So a equal to ar. That's how it is coming. Okay. So a equal to ar. Now a theta is equal to 1 by r d by dr r square theta dot. Okay. So a theta is equal to what? 1 by r d by dr r square theta dot. That is equal to your 0. Okay. Now transverse component of acceleration is 0 in a central force, so this particular quantity is a 0, and that's how transverse component of acceleration is written. And we have already learned this in the previous lectures, that a theta can be written like this, that 1 by r d by dr r square theta dot. We have already learned this. Now 1 by r will go in the right hand side, so it will become 0. And d by dr, so this particular quantity, as r cannot be infinity, so this particular quantity cannot be 0. As r cannot be infinity, so this particular quantity 1 by r cannot be 0. So only this particular quantity has to be 0. As this particular quantity has to be 0, so r square theta dot has to be constant, because only differentiation of a constant yields 0. So this particular quantity has to be constant, because this differential is equal to 0. So as this differential is equal to 0, so this particular quantity must be a constant. Okay. So this particular quantity is a constant. Let's suppose it is equal to h. Let's say this is suppose your equation 1. Now as angular momentum is equal to what? J equal to mr square theta dot. We have already learned in the previous lectures that angular momentum is given like this, J equal to mr square theta dot. So what will happen? R square theta dot will be equal to J by m, angular momentum per unit mass. And angular momentum per unit mass, r square theta dot, we have already assumed to be equal to h, and J by m, that is angular momentum per unit mass, that will be equal to your h, because r square theta dot is h, and J by m equal to r square theta dot, and J by m will be equal to eventually equal to h, because r square theta dot equal to h. Okay, so that's why J by m equal to h from here. Now acceleration of the particle, how will it be given? A equal to ar equal to r double dot minus r theta dot square. We have already found out this particular expression in the previous lectures. Okay. So let us write acceleration to be equal to d2r by dt2. Double rate means double differentiation of displacement is equal to acceleration. Double differentiation of displacement equal to acceleration. That's why. And r double dot equal to it is having two dots above it. Okay, r double dot means what? Sorry, pardon, you are not substituting this. You are basically substituting this. Okay, so r double dot means double differentiation, so d2r by dt2, and r theta dot means single differentiation, so single differentiation over here. Okay, so this is suppose your equation 2. And how did you get this particular term? You got this from the previous lectures. Now let us introduce a new variable u, which is defined like this, that u equal to 1 by r. Suppose you have defined a particular variable u which is new. Okay, so u equal to 1 by r. So we have what? We have dr by dt equal to d by dt of 1 by u. Okay, let us suppose that this particular quantity u equal to 1 by r, basically we are making variable substitution. Why are we making u equal to 1 by r substitution? Because we are making this substitution so that our expression becomes easier. Okay, our expression, this particular r is eliminated, that's why we are doing so. Okay, so we are doing like that. Then dr by dt, what will it be equal to? The d by dt of 1 by u, d by d theta 1 by u, d theta by dt, and this particular quantity will yield you this. How did you get this? This is from the chain rule of differentiation. How did you get this? Why are we assuming u equal to 1 by r? You must remember this thing, that we are finding what? Equation of path or orbit, and equation of path or orbit is always found. Equation of path or orbit is always found in terms of u, and u is equal to your 1 by r. So equation of path or orbit is always written with respect to 1 by r. So that's why we are assuming u equal to 1 by r when we are converting this particular expression in terms of u. Okay, so we can do it. Now dr by dt, how will it be written? D by dt of 1 by u equal to 1 by r, so r will be substituted by 1 by u. So d by dt of 1 by u, then this dt will remain as it is, and d by d theta, so that this d theta and d theta go, and this d by dt will be obtained as it is. So this particular quantity is equal to this particular quantity. I don't think there is any need to explain this, because this d theta and d theta will go. Okay, they will not cancel, but they will go. Okay, they will vanish. So d by d theta of 1 by u, then you will apply the normal rules of differentiation, and you will get this particular quantity. D theta by dt can be written as theta dot minus 1 by u square du by d theta. Now theta dot, we have already found out theta dot, what is it equal to? Theta dot is equal to h by r square. Okay, from here theta dot equal to h by r square. Okay, so theta dot will be substituted by h by r square. So we are converting everything in terms of u. Okay, so this u square and this r square will yield you 1. Okay, this u square and this r square will become 1, and du by d theta h will come to the front, and dr by dt equal to minus h du by d theta. Now this is from by using 1, this is by using 1. I have already told you theta dot equal to h by r square. That's how we are saying by using 1. Okay, so dr by d theta, dr by dt equal to minus h du by d theta. So that's how you can see. Now d2r by dt2, let us do one more time differentiation. d by dt dr by dt. So dr by dt will be minus h du by d theta. So let us substitute. Okay, dr by d theta, in place of that we are substituting minus h du by dr by dt, in place of that we are substituting minus h du by d theta. So d by dt minus h du by d theta, and again we will apply the chain rule of differentiation, and again we got this particular term. Then theta dot can be written as h by r square and h square u square del d2u by d theta 2. Okay, so we are doing what? We are converting this particular expression in terms of u, because u equal to 1 by r, when we are converting it into u, so that we can find the equation of trajectory. That's why we are doing so. Okay, now substituting these values in equation 2. Now how did you get this? I don't need to tell you. Okay, I don't need to tell you all this. Okay, you have applied chain rule over here. This d theta and d theta will go, so it is equal to this, and this term will be d2u by d theta 2. Then d2u by d theta 2 will be written as it is. Okay, so you are converting r into u basically. Okay, so you converted it. So d2u by d theta 2 plus u minus a by h square by u square. Okay, so this is your equation a1. Now a equal to f of r by m. So f of r is equal to f of 1 by u, and h equal to j by m. Okay, so h equal to j by m. How? We have already derived that h equal to j by m. Okay, angular momentum per unit mass, we have already seen it in the previous slide, and r equal to 1 by u, so it is the thing. Now you can write a equal to f of r divided by m. How? F force is equal to mass into acceleration, that's why. Okay, so in place of r 1 by u, so f of 1 by u m. Okay, and this particular quantity remains as it is. So hopefully you got everything. Okay, so you substituted a with this particular quantity, and j by m, so h square will be j by m, so you substituted that also, and 1 m will be cancelled. I think, yes, 1 m will be cancelled. So you can do the steps and see yourself. This is not a big deal. So equation of orbit. Okay, so that's how you can find the equation of orbit of any particular thing. Okay, so this is the equation of orbit which you must remember always. Okay, and how we have reached over here, how we have derived it, you must know this. Okay, so this is a very important derivation which you must take care of. So we will do the next problem in the next class. I think only 2 slides are remaining, right? So as only two slides are remaining, I am completing this over here only. So if equation of orbit of a particle moving in a central force field is r equal to k e to the power alpha theta, k and alpha being positive constant, find the force law. Okay, so you will take, basically you have to convert the this is the equation of orbit. Okay, now what does the question say? Equation of orbit is given in the question, but it is given in terms of r, it is not given in terms of u, but we have found the equation of orbit in terms of u, so we have to convert this r in terms of u first of all. Okay, and we have to find the force law accordingly. So over here in this expression, force law also comes into picture, so we have to find that. Now r equal to k e to the power alpha theta, so u will be equal to 1 by r equal to 1 by k e to the power minus alpha theta. So du by d theta will be equal to minus alpha by k. From here, if you differentiate this, you will realize that you will get this thing. Okay, by the exponential function differentiation formula. Okay, differentiating with respect to theta, then again differentiating with respect to theta, you get this. Now equation of orbit is given like this, so you substitute du by d theta over here, and d2u by d2u by d theta 2, that is double differentiation with respect to theta, you substitute over here. Single differentiation with respect to theta, you substitute over here. So you get this. Okay, this particular term. How did you get this? d2u by d theta 2, you substituted this, you substituted like this. Okay, and this particular term remains as it is. So that's how you have done. And over here also in the place of u, you can substitute this particular term. Okay, because everything is given in terms of r over here, so we are converting it into u, because equation of trajectory we have in terms of u. Okay, so everything is given in terms of r, so convert everything into u, and then equation of orbit you know in terms of u, substitute the corresponding values. This is the term which you will get. Then what will happen? then what will happen? Then you will take e to the power minus alpha theta, e to the power minus alpha theta divided by k as constant. From here you will get this. Then f of 1 by u, you get like this. Okay, so 1 by u is your r. Okay, so now how did this come? Okay, now how did this particular quantity be equal to c by r cube? This is what you must note from here. Okay, so this particular quantity j square 1 plus alpha square m, this is what, this is constant. This will be constant for a particular system always. Okay, but what will vary? E to the power 3 alpha theta will vary. Now e to the power 3 alpha theta, that is also 1 upon. Okay, now you know this very well, that this is the thing how r is given. Okay, so your r is given like k e to the power alpha theta, k e to the power alpha theta. Okay, so if I try to take cube on both sides, then it will be k cube e to the power 3 alpha theta. Okay, now look at this particular slide carefully. Okay, look over here carefully. Look over here carefully. This particular term, isn't that equal to r cube? Yes, that particular term is equal to r cube. So that will be equal to r cube. And your c, this particular term is equal to r cube. So you are substituted by r cube, and your c will be equal to what? Your c will not be equal to this. Okay, just make sure that when you make the notes, remove this particular term from here. Remove this k cube. Okay, remove this k cube from here. Remove this k cube from here. Okay, remove this k cube. This k cube is wrongly written. Okay, this k cube is wrongly written. Okay, so this is constant, and this k cube e to the power 3 alpha theta will be equal to r cube. From where? From this particular definition given in the question itself. Okay, so hopefully you got this. So that's how you found the force law, that is force is inversely proportional to r cube. Okay, so it is inversely proportional to minus r cube. Okay, so that's how you found out. So the lecture is over now. So thank you very much. Hopefully you got it. And if you haven't understand anything, okay, if you haven't understand anything, then please note everything down in the notebook properly. Note everything down in the notebook properly. Go to the lecture once again, and you will understand each and everything very clearly. Okay, thank you very much.